Good day, good morning, good afternoon, good evening. It's Daniel Willis with Fike Corporation, National Sales Manager. I want to introduce our presenter today, Michael Hunt. He's the European Business Development Manager. And take it away, Michael.
Thank you, Daniel. Okay, thank you for joining our webinar today. Our focus will be on methods to reduce emissions in a typical sealed system. There'll be an opportunity to ask questions at the end. Any questions that we can't fully answer due to time constraints or whatever, we'll get back to you individually. So don't hesitate. And if you can send us an email request at any time. Okay, a few weeks ago, we had the COP27 summit discussing the climate crisis, highlighting the need for industries to reduce their emissions of greenhouse gases. Control and reduction of emissions is now taking center stage. So a few years ago, there was a similar pressure to reduce emissions for ozone depleting gases. These were predominantly the SF6 and the chlorofluorocarbons. And if you recall, they were used in absolutely everything from aerosol propellants to fridges. And in that example, it was a combination of phasing them out, but also substantially reducing leakage. In the case of the hydrocarbons and CO2 emissions, phasing out, it's not really an option in the short term. However, the chemical, petrochemical and process industries have a vested interest in reducing wasteful and harmful emissions from the production process, and much effort is already given to reduction. Additionally, carbon capture technology, it's rapidly evolving. It is expensive, but the alternative is much worse. But there's no doubt that industry is taking this seriously and it's costing money. The pressure to act, it's coming from shareholders, lobbyists, public opinion. So most refinery and petrochemical production processes take place at temperature and under pressure in a closed loop system. This is both to enhance the efficiency and prevent product loss. So, chemical production processes, it's rather like an upscaled kitchen. So reactions happen more efficiently at an increased temperature, which goes hand in hand with increased pressure. There is obviously a danger from operating at high pressure in a closed system. So individuals and equipment need to be constantly protected. So whilst pressure regulating and controlling systems are very sophisticated, things can and do go wrong. So there is always a need for the ultimate safety device to be non-mechanical, so basically able to work on its own without any human intervention or interaction. So if everything goes wrong, there's a power outage, a fire, a runaway exothermic reaction, whatever it is, something is in place to prevent that surge in pressure from destroying the whole plant. So two of the most widely used devices to offer protection in a case where the pressure has exceeded the defined safety limits are the pressure relief valve and the rupture disc. So a pressure relief valve, it relies on a spring to keep it closed, and it will open at a calibrated specified pressure and continue venting until the pressure subsides. The set pressure, relieving capacity and flow rate are all carefully calculated to ensure that after opening, the pressure in the system is vented. It will not exceed a predetermined set level. This is usually the maximum allowable working pressure, known as the MAWP. Once the pressure in the system normalizes to a safe level, the valve recloses, effectively resealing the system to prevent further loss. But when selecting a pressure relief valve, one should consider the following. Basically, the wetted parts of the valve should be resistant to the process media. Certain processes produce product that could potentially cause blockages in the valve inlet. For example, waxes or polymers or resins So ongoing maintenance is required to ensure safe operation, including regular testing, removal, and recalibration if required. The initial cost of a safety relief valve, especially if it's in an exotic ally or it's a large size, can be quite substantial. And finally, a typical metal-metal seal, it's never going to be 100% leak tight. The API does in fact actually allow it, has a table of acceptable leak rates for valves. See there. So if you see on the chart, so even the most conservative case, a small low pressure relief valve, it's permitted to emit 40 bubbles a minute. So bear in mind that many refineries have many thousands of pressure relief valves running 24 hours a day. So total emissions can be substantial. So in addition to the pressure losses, there is the possibility for media to weep through the valve seats. This will naturally increase over time through wear and tear as the valves age. And leak rates increase as the pressure increases, especially when you get near to the set pressure and the valve actually begins to what's called chatter. Additionally, small molecular elements, such as some halides, but especially other elements such as hydrogen and helium, are extremely hard to contain due to their very small molecular size that will pass through the smallest gap. And also note that aggressive or corrosive media may actually cause a leak path. So another widely used pressure relieving device is the rupture disc, also known as the bursting disc. So much like the safety relief valve, it is designed to burst or rupture at a predetermined pressure, and in the case of a rupture disc, at a coincident temperature. It is non-reclosing. This is a fundamental difference. It is non-reclosing. This is the safety valve or safety device of last resort. So basically, it breaks before the process equipment blows up. So when all other interventions have failed to stop the runaway reaction, the fire, or the continuing increase in pressure for whatever reason, the disc has to burst. But note, when it bursts, the entire vessel, all the system, the entire pressure in the system is lost. All the contained pressure is gone, and quite possibly most of the contents. So you sort of imagine it a bit like a cork on a champagne bottle. It's the designed weak spot in a system. It's designed to break and relieve pressure when all other mechanical control systems have failed. So what are the attributes that we should consider? Ideally, it should be non-fragmenting, especially if there's something downstream. The idea of high pressure metal fragments flying down the system is not good. It's possible to have a very high operating ratio with a rupture disc, up to 95% of the set pressure, according to ASME, the stamped pressure on the disc, without harm or leakage. It has a very low flow resistance, and KR values are provided by Fike to assist in system design. There's a wide range of available materials to be compatible with processes, from 316 stainless steel as a standard to Inconel, Hastelloy, all standard materials. You should consider is vacuum resistance important. Basically, the lowest possible level of leakage is literally bubble tight, the rupture disc. They meet all recognized standards, CE, ASME, etc., and suitable for all process media, gas, liquid, two-phase flow. And most importantly for this presentation, they're compatible for use with safety relief valves. So as with a valve, the wetted parts should be resistant to the process media. Typically, the disc can be mounted close, even flush with the process media. So there's no inlet to plug with wax or polymeric type product. discs tend to be viewed as a sort of fit and forget item. So there's no ongoing services required. They're replaced when they operate, when they burst, or on major shutdowns. The initial cost of a rupture disc or a rupture disc assembly is typically a lot less than a valve, especially when exotic or chemically resistant alloys are involved or the sizes are large. Leakage and emissions are absolutely minimal, even when tested with helium. So comparing the difference between them, typically when tested with helium, a pressure relief valve might reasonably pass 100 bubbles a minute. The rupture disc, in contrast, would literally be less than a bubble a minute and effectively none if the unit is welded. So rupture discs are used where zero leakage is vital, such as in pharma and biochem industries, where product contamination is critical. Whilst the huge benefit of the safety relief valve is that it is reclosing. So it reseals the system after venting, thereby preventing further loss of product. So this leads to the solution. Fike's Valve Guard is one of the most widely used throughout industry, and it's a combination of a rupture disc and a pressure relief valve in series. So in reality, around 60% of rupture disc applications are to isolate safety relief valves. It's one of the most widely used disc applications. So you get the best of both worlds: leak tight and system reclosing. So in this picture, you see a typical setup where there's a 1/4-inch tapping, T-piece, excess flow valve, pressure gauge. It's required by the codes to monitor the interspace between a rupture disc and a valve seat to prevent any buildup of pressure in the interspace. For example, thermal expansion in the chamber, or in extreme cases from pinhole leakage of the disc, maybe through chemical corrosion. This is because the rupture disc needs to operate as a pressure differential membrane, so any pressure behind the disc needs to be considered, as it will work as a back pressure against the disc. As the disc sits upstream of the valve, it protects the valve, leaving it in as new condition. Only when the dangerous set pressure is reached will the disc open and vent through the valve. This allows the process to be operated at higher pressures, even closer to the set pressure, at 95% of it, which is something appreciated by valve operatives, without any weeping or chattering of the valve seat, thereby greatly reducing emissions. So in addition to the higher operating ratios, there are additional benefits. So lower overall costs are possible. You can isolate a carbon steel valve with a stainless steel rupture disc, for example, or Hastelloy. You get reduced maintenance, reduced downtime, extend the life of the valve, and it even allows for in situ testing of hard to reach PSVs, since it's possible to inject gas between the disc and the valve seat and actually pop test the valve in situ. A typical rupture disc that Fike would recommend for isolating a safety relief valve would be one of the latest G2 developments, the Axios RD520 or Atlas RD500 for higher pressures. Since these precision non-fragmenting rupture discs allow for a genuine operating ratio of 95% of the stamped burst pressure, according to ASME, or 100% of the minimum performance tolerance, as specified by the PD ISO 4126. So they have an extremely high resistance level to pressure cycles and pulsations. The holder heights themselves can be adapted to guarantee clearance to the valve seats. So in summary, the safety relief valve will eliminate emissions whilst the disc is intact. The system pressure is contained after returning to the pressure norms. The process can continue until a controlled shutdown allows the disc to be replaced. Control over the system is maintained at all times. It's a relatively low-cost solution to the problem of media loss through leakage that can be retrofitted onto existing leaking valves. So this is a nice cutaway that you can see the location of the rupture disc and clearly understand the concept of isolating the valve. Now, if you have any questions, we'll be happy to answer them either now or later if you want to submit by email. And thank you very much for your time and attention.
So just waiting for questions to pop in here. So I see a question here. It says, does using a rupture disc affect the flow capacity of the relief valve or the assembly?
Yes, we'll answer that one. It does. The code stipulate that if you have a rupture disc and relief valve in combination, the valve should be rated by 10%. So typically a derate factor of 0.9, a combination capacity factor of 0.9 is used. In reality, the flow resistance from a rupture disc is much less than that. And what the code does allow you to do is, if the rupture disc and valve have been actually tested in combination, as many valves and Fike discs have been tested in combination, you're allowed to use the actual capacity calculated, the actual flow calculation, which in many times is 0.99, so virtually none at all. But if it's an unknown valve with an untested valve with a rupture disc, yes, it's downrated by a factor of 0.9.
Nice, thank you, Michael. Another question that's here: are there any special requirements when using a rupture disc under a pressure relief valve?
Okay, special requirements for the rupture disc. The most important one is that the disc itself should be non-fragmenting. Okay. And then it's also important to make sure that the chamber between the rupture disc, as you see on the photo, the chamber between the rupture disc and the valve seat, that must be free venting. So the code stipulate that the interspace must be monitored to ensure that there is no pressure between it. There's a variety of methods of monitoring it, and it can be a sealed system, providing you have an Emerson, Rosemount, that sort of a pressure switch on there. But the simplest way to do it is to have an excess flow valve, a pressure gauge, and a tricock, as you see here. But often you can have a pressure switch in the system, so that when the disc bursts, the valve opens and there is pressure in the system, as well as it being read on the pressure gauge. An alarm is sent to the control center, for example, so they can, shut down the system in a controlled manner.
Okay, thank you, Michael. Let's see, the next one: do you have disc types that do not damage PRVs when they relieve into the pressure relief valve?
Yes, every disc that we would supply for isolating a relief valve would be designed to be to not damage the valve seat. So the only way the valve could be potentially damaged by a rupture disc would be if the disc fragmented, one, or the other way would be if the petal, as a disc opens, it opens into either a single petal or four little petals. So there must be a distance between the disc itself and the valve seat, and the holders that Fike supply when isolating a relief valve, the holder encapsulates the petal, so that won't be the case.
Okay, thank you. I'm reading one here. When a rupture disc in combination series with a pressure relief valve can burst sensors potentially fragmenting be used?
It's not a good idea to use a burst sensor. A pressure switch would be a better way to do it, rather than having a sensor if it's isolating the relief valve. The sensor itself doesn't have there's no parts to it which would prevent a valve from reseating, so it's not inherently dangerous. But you would get the small the small particles of the sensor would end up being, going downstream, so it would be unadvisable.
All right. One more is what leak rate do rupture discs have?
Okay, well, typically, as we said before, they are bubble tight. A relatively basic rupture disc will have a leak rate of a helium leak rate of about 10 to the minus 4. One of the later generation of discs typically have a leak rate of about a helium leak rate of 10 to the minus 6. So that's millibars liters per second, which is it's the sort of leak rate. And an example is if you had something like mercaptanes. So the manufacture of mercaptanes, that is the stenchant used in gas to make gas smell. And quite literally, one part in billions you can detect and you can smell. And the idea is that you can have a system, a sealed system, using a rupture disc isolating that, where you can prevent that sort of leakage, or in pharmaceutical applications where you can have literally zero leakage. And if the disc is on a welded unit, it will have a leak rate of 10 to the minus 8, which is, it's impossible to get. There's just nothing will leak out of it. I mean, when you have elements such as hydrogen, people talk about hydrogen being such a small searching molecule that if it's in a steel bottle, over hundreds of years, it will actually pass through the steel bottle, because the molecule is so small. But the effective leak rate from a rupture disc is more than bubble tight. It's completely sealed.
Okay. Yeah, perfect. Have just one moment. Let me pull this up and see what it is. Let's see, what are the largest diameters of the two rupture discs and the KR values? We may have to look up the KR values. But Michael, do you know the largest of the 500s and the 300 series?
Sorry, can you repeat the question? The KR value?
Well, the KR values of the 500 and the the 500 and the 520 series, and then also the largest diameter. I can answer the largest diameter on the 500 series. I believe the largest diameter that we have currently is a 40-inch, and the
KR values are on the data sheet actually.
Yeah, and the 520 the disc is a 12-inch. So it depends on the size as to, it depends on the style as to the maximum size that you can get to on that, on the style of disc. Sorry, I'm looking at the notes here. 1 sec. So welded disc, there's a question, can we discuss welded disc? That's kind of an open-ended question. But we certainly can weld the outer diameter of the rupture disc and making it a cartridge type assembly for sealing the rupture disc, so there will be absolutely no leakage. As Michael was talking about, the use of the O-rings or standard seating, or certainly seal welding, will prevent any emissions. 1 second here.
I saw a message on my phone actually from Caroline regarding a bellows. Is that? Didn't really see the full question there. If we haven't been able to answer any questions right away, we will get back to you as an audience individually.
Yes, having a bit of trouble seeing the question here, so I think that we will have to we'll get back to answering all those questions to the folks that asked questions, and we can take care of those as the post webinar. So thank you very much for attending, and please send us any questions, and we will answer those questions certainly as possible. Thank you very much, Michael.
It's a pleasure.